Now that we have some background and we understand what predicate logic or quantifier logic or categorical logic is all about, let's look at some valid, logically strong or well-formed patterns of inference within predicate logic. Because remember, we're looking at patterns of inference because we've discovered that what makes the logic work, what makes inferences good inferences, are the patterns that they follow. So if we see what are good patterns and what are bad patterns, we're going to recognize what kind of inferences are good and what kind of inferences are bad. So let's go back to our original example. Socrates is a man and all men are mortal, therefore Socrates is a man. Well, if we were going to reconstruct that argument, it's kind of simple reconstruction, right? The conclusion is Socrates is mortal. One of the premises is Socrates is a man. The other premise is all men are mortal. So we see that this inference is, intuitively we see it's a valid inference, and this has been our example of, par excellence, the paradigm, the perfect example of a valid inference in logic, a valid deductive inference. But we can also see that it has a certain pattern. Remember, we saw that all A's are B's. That's the first premise, was the way. Now look, we have Socrates is a man. Now this one's a little bit different than anything that we've used before. And sometimes when we're looking at predicate, and by the way, A's and B's, I should mention, they're arbitrary. They're chosen arbitrary, that A stands for some category, B for some other category or some other predicate, A a predicate, B a predicate. But here we have an individual Socrates is, in a certain category. So for those, arbitrarily we choose letters from the end of the alphabet, starting usually with X. X is an A, so that represents Socrates as a man. Therefore, X is a B. And we've decided this is a valid pattern of inference, right? So any inference that's of this form is going to be a good inference. That is, it's impossible for the premises to be true. You can't fill in this argument in such a way that the premises are going to be true and the conclusion's false. Now we start the first premise. We say all A's are B's, which, remember, from that diagram perspective, the diagram, if you find it helpful, great. If not, don't worry about it. But what the first premise says is the circle, the category, all things that are in A, that are A's, is within the bigger circle of all the things that are B's. So all A's are B's. And then the next premise says X is an A, so it says X goes into that category. In that same circle, we're going to find it with all of the A's. And you can see, well, if X is in that circle, X is in the bigger circle. So X is a B, which is why that diagram shows you that this is a good inference. But we can see all arguments of this form having this pattern are valid. That is, the conclusion follows of necessity from the premises. So for example, if we change our A's and B's, let's make A mothers and B's female. So all mothers are female. We'll change X. We'll let that represent Beyonce. Beyonce is a mother. Therefore, Beyonce is a female. So not only is all males or all men are mortal, Socrates is a man, therefore Socrates is immortal, but every inference that uses this pattern is a good inference. Now let me just test you a second. Does that mean that any argument of that form is good? And the answer is not necessarily, because a good argument needs two things, right? It needs to have good logic, which anything in this pattern has good logic, but it also needs true premises. But now all we're worried about is the logic, so let's just worry about the inferences, the patterns of inference.